In this unit, we'll be looking at the paired t-test. It is one of the t-tests we run. We actually conduct it when we have two groups that are related. That is a case of before and after. It is a test we use in also checking differences between two groups. One of the assumptions, or the major assumption rather, besides that of normality, is that the groups must be related. So it is expected that at the end of this unit, you should be able to conduct the pair tests and also interpret the results. Let's see how we can do as regards the application. The exercise says to determine the effectiveness of a certain drug for reducing high blood pressure. The BPs of 20 randomly selected patients with high blood pressure were recorded. After administering the drug for 1 week, the BPs of these patients were recorded. So what's the activity we have? It says you are required to analyze the data and inform the medical unit on the effectiveness of the drug. Okay, so what do we do? You seeing that this case is a before and after case, I will conduct the paired t-test. But before we go ahead to do that, let us look at the hypothesis. For this test, it says there is no significant difference between the blood pressures measured before and after. The alternative says there is a significant difference between the blood pressures measured before and after. And our decision rule says we will reject the null hypothesis if the p-value is less than the alpha. Otherwise, we will not. And remember, our p-value is 5%, right? That is 0.05. So let's move to Excel, where we have this data and see what we can do. This is the data. If you look into your exercise files folder, you will see the file called paired tests. Okay, so we have the before and after. So when you are running a paired t-test in SPSS, you don't have to rearrange or stack the data like we did for independent samples t-test. What we do is we just copy the data the way it is. I highlighted and I've copied. Move to SPSS. Right click in your data view, right click and click paste. So go to variable view and we'll define this before. We'll call it before. Press your enter on your keyboard and call this after. Okay, so we'll go to our label to expressly define this. So we'll say patient's blood pressure before the drug. Let's say before the drug. So patient's blood pressure after the drug. So we'll go to measure and tell it that it is scale. It is also scale for the second one because the two of them are quantitative variables. Okay, so we now, to analyze the data, we go to analyze. From there, we'll go to compare means, moving and click on paired samples test. So we have our variable 1 and variable 2. Click on the first one and click this arrow. It enters, or you drag and drop it there. Let's drag this one and drop it there. So you see, SPSS gives you room to run as many pair tests as you have. If you have more data that you're running also pair tests, as you enter them, it gives you the next pair. You can run as many as you want at once. So when you've done this, click OK to run it. So we have our result out. Now the first table says pair samples statistics. This is where it gives you the descriptive statistics of the two groups. Let's move straight to the next table, that is the pair samples correlations. This is where it runs the assumption test to ascertain that the two variables are correlated. Because if they are not correlated, then there is no need for a paired samples test. Now, if you look at the result of our correlation analysis here, you see that the correlation is quite high. The p-value says it's significant, which is good, meaning that there is a correlation between the two variables. But you can interpret with this value without minding the p-value. This value, which is 0.996, shows a very strong positive correlation between the two of them. It's almost 1. if approximately becomes 1. And when there is this high correlation, that means they are very much correlated. When we have such value as 0.9 or even 0.8 something, that's quite high. So we are good on that part. We did not violate the assumption of being related. So let's move to our test. This is the result of our test, pair samples test. This here is the mean difference, 119.8 and 119.75. So this is the difference, and we go further down here to see the t calculated. This is the t calculated, 0.170, and this is the p-value. Our p-value is 0.867. That's quite high. And remember that when the p-value is less than the alpha, our alpha is 0.05, right? So when the p-value is less than the alpha, we conclude that the test is significant and we reject our null hypothesis. But in this case, our p-value is not less than our alpha, that is, it is greater. So when it is like this, we say that the test is not significant. So we fail to reject our null hypothesis. And you know that our hypothesis says that there is no significant difference between the blood pressures of the patients before and after. So if this is the case, that means the drug is not effective. So if we have to advise the medical unit on this, we will tell them that the drug is not effective. They should not administer it as a treatment for blood pressure to reduce blood pressure. They should maybe get another drug to be tested. So this is how we've done it. Thank you for being in this unit all this while. We'll move over to the next unit, but remember to go to the exercise file and try out the trainee hands-on. Thank you very much.